Okay, so in this video we're going to be looking at scientific notation. So a school has 1,151 students in it. What would the scientific notation of this number be? What we need to do is we need to move the decimal place to represent the number as a number between 1 and 10, with then multiplied by however many factors of 10 we need. So in this case, 1.151 times 10, and we need to figure out the factor here. We move the decimal place 3 places over, 1, 2, 3, so it is times 10 to the third, and that's how you would represent this number. Now let's look at a smaller number. What if you had a really rough test and you earned a grade of 0.0063 out of 100? Not your best day. What's your grade going to be in scientific notation? Let's try to make you feel at least a little bit better about your grade. So we're going to convert this to 6.3. Okay, it's to a factor of 10. And in this case, if we go up here and we count, we're going to move the decimal place over 1, 2, 3, 4 places to the right. So that would be 10 to the negative fourth. So you've got a 6 is the good news, but it's times 10 to the negative fourth. That's the bad news. So now we're going to do a problem with scientific notation and significant figures. So what if the number changed to 1,150 students? Let's say the student who had a 6.3 times 10 to the negative fourth on their last test did not actually make it through the year, and now we want to represent this as scientific notation. The problem is going to be this sort of ambiguity of the may or may not count the zeros to the right as being significant. So let's assume for a second that this number was given to us as just this. You had 1,150 students. You didn't know whether every student was counted individually or maybe we rounded it. Well, without that certainty of it, you might call it 1.15 times 10 to the third and leave the 0 out, and this would have 3 significant figures. If you knew, however, that every student was counted, previously it was 1,150, we lost 151, sorry, we lost 1, we're at 1,150, then you could use that 0, 1.150, times 10 to the third. And if we remember, zeros to the right of the decimal, if there's a number greater than 1, count as significant figures. So this now has 4 significant figures. And assuming they were counting every student, this would probably be a better representation.